solid. So now let's figure out how to get the volume of the rectangular solid. So to do that, let's first put the dimensions. So here for a solid geometry where we have, as I told you earlier, that we have 3 dimensions. So let's put that. Here we have a length, which is, let's say DC is length L. Then this is CF, is width is W, and the height, which is BC, which is H. Now the area of the rectangular solid, so area is LWH. Now you can see it follows quite logically, because if you see the area of this surface, okay, area of this surface is L times W, and if you stack up lots of such rectangular pieces to cover the entire solid, you probably get something equivalent to H. So then you will come up with an area LWH. So that's kind of a way to remember the area in case you find it difficult. Now one thing is that length, width, and height, so depending on how you what is the orientation, you can mark any dimension as length, width, and height. So for another rectangle, you can assume this is, let's say, width, this one instead of L. So those really don't matter. All you need to know is there are 3 dimensions, and the area of the sorry, this is not area, the volume. The volume of the rectangular solid is LWH. So I did a mistake. Excuse me for that. So volume. Now the surface area. So the surface area. Now surface area of a rectangular solid is the addition of all the surfaces. Now how many surfaces we have? So let's say one is, let me choose a different color. So let's choose maybe green. So how many surfaces we have? So we have, if you look at from this direction, we have one surface here, we have one surface here, one top and bottom. So 4 surfaces. Then we have one surface at the side. So I think all total we have 6 surfaces, and then we have surface at the back. So each of the surfaces, so there are 6 surfaces, and if you see each of the surface, so this A, B, C, D from the front side, the surface area is L times H. Now at the back also there is a similar surface, so we have 2 LH. So let me write it down, 2 LH plus, now we have surface at the side surface, which is W times, what is the length of this? H. So this surface is W times H. Now we have another surface also, which is just a mirror of this surface, which is this one. So that makes another 2 times WH. So we have covered already 4 surfaces, 2 more surfaces remaining, which is the top surface and the bottom surface. So which is top surface is, what are the dimensions here? We have L, which is this one, and we have this W. So 2 times LW. So if you take 2 common, then you have LH plus WH plus WL. So this is the surface area of the rectangular solid. So again, we express it in 3 dimensions. So if you see, all possible combination of dimensions exist here. You have LH, WH, and WL. So that's the way to remember. If you're given 3 dimensions, you make all possible combinations. Now, the other way, if you have difficulty to remember this theorem, one way to is that it's very easy to find out, because you just add all the surface areas, and surface areas you apply the principles what you learned in plane geometry, which is rectangular, an area of a rectangular surface area is its height times width, or multiplication of its two dimensions. So let me draw it here. Let's say if you are given any area, as what you have learned in plane geometry, the area of this surface is its this dimension times this dimension, and all we are doing here is that adding all those dimensions here. Now let's there is another property of rectangular solid, which is the diagonal. So to show the diagonal, let me choose a different color so that it is a little bit clear. We choose blue here. Okay, so if you see in this surface area, if you're looking from this side, the front surface area, it has a diagonal here which goes from this side. But then there is another and each of the surfaces has similar diagonals. Now these diagonals we have done in plane geometry, but for a solid geometry you have another diagonal where it comes from this corner. Let me draw, let's see if and it goes to this corner. Now this is called long diagonal of a rectangular solid. So this is, now let's try to find out what is this diagonal. What is this length of this diagonal? So if you see, to find it out, you can, if you see this triangle, okay, let me put name here A, let's say H. If you consider this triangle ACH, see, this is a rectangular triangle because, okay, let me draw it here, because this angle is 90 degree. So we can apply Pythagorean theorem. So now we know this is W. What is this? We know if we apply the Pythagorean theorem of ADC, we will find AC square, because for this triangle this is a rectangle, so AC square equals to AD square, which is H, AD square plus DC square, which is L square, which is this. Now for this triangle, what we're trying to find out is HC. So HC square equals to, okay, HC square equals to W square, which is AA. Okay, let me write AH square plus AC square equals to W square plus AC square. We have find out already here, H square plus L square. So let's look at this. Let's look at this one carefully again. What we have here is the long diagonal of a rectangular solid is actually the square root of each of these dimensions, W square plus H square plus L square. So HC, which is our long diagonal, is W square plus H square plus L square. So is that clear? And the way we did it is that just by applying basic Pythagorean theorem 2 times, one to find out the diagonal of one surface area, and then applying that to find out the long diagonal.